Okay, these notes are theoretical and percent yield. The theoretical yield in a reaction is the amount of product you should get. You usually don't get that much, but that's how much you're supposed to get when you perform the reaction in the lab. You get this value by performing a mass-to-mass calculation. Now, the percent yield is the percent of the theoretical yield that you actually got in the lab performing the reaction. Guys, if you do a percent yield calculation and you get over 100%, you screwed up somewhere. If you get a lot less than 100%, you screwed up somewhere. Generally, most reactions that we'll do when we do lab work yields between 85 and 90% generally. Not always, but sometimes, most of the time. Now, there are reactions out there that, if you get a 22% yield, you've done a great job. So it really all depends on the type of reaction that it is. This is calculated by dividing the actual yield by the theoretical yield, then multiplying by 100. So let me write the equation down. It's actual yield divided by theoretical yield times 100. Okay? Okay, so let's try an example. First off, let me put my 55.85 grams, 32 grams, and 159.7 grams. By the end of the school year, you will know those values by heart, if you don't already. Okay, so we're saying that 60.7 grams of rust was obtained. Okay, guys, this is the actual yield, because they're saying that when we did the experiment, this is what we got. This is not what you use in your picket fences. Do not use this number until you get down to calculating the percent yield, okay? So this is the actual yield, because it says this was obtained. When you see the words was obtained, that's the actual yield. So now it's saying from the oxidation of 50 grams of iron. This is what we're starting with, okay? So this is our starting substance. That's what we're going to put in the picket fence. Okay, so let's do this. So we're going to take 50.0 grams of iron, so of Fe. And then we're going to do, now right now we're going to go from grams. We need to go from grams to mold. We do that by putting the molar mass here. For those of you that are doing the three-step method, okay, this first step, you're going to take the 50 grams of iron and divide it by the molar mass, and you'll get some amount of moles, okay? And then at that point, you need to do a mole-to-mole conversion using a picket fence. So it's 1 mole of Fe. So you're going to put the 4 moles of Fe here, 2 moles of Fe2O3. Okay, this will get you the moles of Fe2O3, and then now you have to multiply by molar mass. Okay, 159.7 grams of Fe2O3. And this gives us 71.5 grams of Fe2O3. Okay, now we're going to take the 60.7 grams, because that's our actual yield, divided by 71.5 grams, and then we're going to multiply it by 100, and we get 84.9% yield. Okay, this is our theoretical yield, by the way, our TY. If you want to see this using the three-step method, ask me tomorrow in class and I will do that for you, okay? But otherwise, try and do the three-step method and see if you can get the 71.5 grams. So the three-step method would be taking this 50 grams of iron, divided by the molar mass, you'll get moles of iron, then do the mole-to-mole conversion from iron to iron 3 oxide, or rust, okay? And then take that moles and multiply it by the molar mass of rust. So hopefully you can follow that. sometimes you need to calculate the percent error. You do this by, now there's a way to do it using it's the actual yield minus the theoretical yield divided by theoretical yield times 100, and that really was kind of complicated. But the easy way of doing this is to take 100% minus your percent yield, and this is actually your percent error. Okay, so in our case, we have 100 minus 84.9, so we have a 15.1% error. Okay, not too difficult, right? Well, that's pretty much it for these notes. So if you have any questions, please ask me tomorrow in class. But we'll be working on 812 to 816 tomorrow, which are very, very easy. So I don't think you guys will have any problems. Okay, so I guess I will see you tomorrow. Bye. Okay, then there are times when you need to calculate actual yield. So to calculate the actual yield, this is if you're given the amount. So you have to calculate the theoretical yield, but then you're just given the percent yield. You're not given the actual yield. So actual yield is the theoretical yield. Theoretical yield times the percent yield divided by 100. Now, if you'll recall, percent yield divided by 100 basically is the decimal equivalent. So 75% is 0.75. Okay, I think you can handle that. Okay, so let's look at, well, let me first put this down as example 2, because this is our second example. Now, we're still using the 4Fe plus 3O2 yields 2Fe2O3. Now, how much rust was obtained from the combustion of 50 grams of iron if there was a 78.9% yield? Now, if you recall in example 1, we actually calculated the theoretical yield of the rust. Okay, we did the whole picket fence. We took 50 divided by 55.85 grams, which is the molar mass, did the mole ratio, and then multiplied by the molar mass of Fe2O3. So we calculated our theoretical yield, and I'm going to call it Ty. That was 71.5 grams of Fe2O3. So now we need to find the actual yield. So if you recall, actual yield is the theoretical yield, so that's the 71.5 grams, times the percent yield divided by 100. Now, if you want to put it in your calculator, you can do it exactly like I've got it written here in your calculator, and it will come out. Otherwise, you have to put in 71.5 times 0.789. So whichever way you want to do, it's fine. It comes out to be 56.4 grams of Fe2O3. Okay? And that would be your final answer on that one. So don't forget, this was done by picket fence. But we did it in the previous example, so I really didn't feel like showing you how to do it again when it was the exact same number. Okay? So hopefully you understand this. And I guess we'll do 8.12 to 8.16 after a warm-up in class. Bye.